Okay, so now we've got the free response question for Unit 5. So here we've got a nonlinear spring, and we're looking at graphs. The AP free response loves graphs, and they're kind of particular about things with their graphs. So, and if you notice here, it says be sure to show your work and specify the units, because that means they're going to assign points to that. And so let's take a look at our rubric here. Okay, so for part A, you get a point for correctly calculating constant A. You could have used either the left hand or the right hand graph substituting in. So if you use the right hand graph, you would have found the slope of the line. And so you would have found the slope to be 25.5 newtons per meters to the 1/2 power. And so showing that work is a point. Then having a numerical value that ranges somewhere between 23 and 27 would be a point, and then having the correct units is another point. So that's why they were so particular on finding on saying show the units. Okay? And then let me go back to the problem. Part B, you're going to determine expression for the work done in compressing the spring a distance of x. Since this is a nonlinear spring, you can't just use force equals negative kx to plug into your work. Now your force is equal to ax to the 1/2. And you need to explain in a few sentences how you could use one or both of the graphs to estimate the numerical value that you find in the first part of the answer. So, part B. Again, since you're doing it over some distance and you have a function, you're going to want to use work as the integral of force dot, they say ds here. If you had used x, that's fine. Okay, so you get a point for having that formula down. So always write your formulas. Okay. Substituting in the correct expression for force gets you a point, and setting the correct limits from 0 to x got you another point. Doing the actual correct integration gets you the 4th point for part 1 of part B. For part 2, for those points, you could say you could find the area equal under the curve for the left-hand graph, or having a correct explanation for obtaining the area under the graph, so some type of points there. Okay, part C, let's go back to the question and make sure we know what we're being asked. Oops, wrong file. For part C, the spring is mounted horizontally on a countertop that is 3.1 meters high, so that its equilibrium position is just at the edge of the countertop. The spring is compressed so that it stores 0.2 joules of energy and is then used to launch a ball of a mass of 0.10 kilograms horizontally from the countertop. Neglect friction. Determine the horizontal distance d from the edge of the countertop. So we've also got conservation of energy going on in this problem too. So using conservation of energy gets you a point. Here there's not an actual statement point. But I still always like to make that statement point because you never know when it's going to be there. Okay, your initial potential energy is going to be what's stored in the spring. Your kinetic energy is going to be equal to that. Okay, so you substitute in the value for your potential energy, and you solve for the velocity as the ball leaves the countertop, or I'm sorry, yes, as the ball leaves the countertop, okay? And then you're into kinematics, so you're going to find how long it takes before the ball hits the ground. And then you can determine the distance it moves, because you know horizontal velocity is not going to change. You know that the time it takes to fall is going to be the same as if you dropped the ball, and so now you can find the distance that the ball will travel horizontally from the countertop, and that's 1 meter. Okay? Any questions further than this, you just let me know.